Raghu? Yogi. Hello.
Sir.
Shall we start the session?
Yes, sir.
Ashish sir, are you there?
ఒక్కసారి స్పీకర్ గారు ఉన్నారా చూడు.
Ashish sir?
Yes, sir, I'm here.
Yeah, sir. Can you hear me, sir?
Yes.
Sir, could you please share your screen?
I can start.
Yeah. Okay. So with your permission, we'll start the session, sir. కొన్నితో కొంచెం my dear participants, good evening to all of you and welcome you once again. Sir, kindly mute your sir. Sir. So, my dear participants, good evening to all of you and I welcome you for the 5th day FDP, online FDP sponsored by AICT and JNTU in collaboration with SRIT Raghu. Today we have two eminent speakers. One is Dr. Ashish Chandra Pathy and another one is Dr. C.H. Chandra Naidu. So the first session is by Dr. Ashish Chandra Pathy. He is going to give a lecture on application of geospatial technologies for disaster management. I'll just give a brief introduction about Ashish ji. Yeah. So Dr. Ashish Chandra Pathy is a reputed academician and expert in geospatial studies. He is currently an assistant professor stage 2 in the Department of Geography at Utkal University with advanced qualification of MPhil and PhD, and he is having a certificate of disaster management and humanitarian assistance, which will be called as CDMHA from the University of Hawaii, US, and the Asian Institute of Technology. Dr. Pathy is well known for his work in urban planning, GIS, and remote sensing. Sir completed his PhD at Utkal University, where his research focused mainly on land use analysis and suitability assessment for the development of green belts in Bureshwar area. And his guide is Professor G.K. Pandey. And in addition to his teaching, he has worked as a GIS consultant for the prestigious organizations such as NIC and Asian Development Bank and the Department of Water Resources, Government of Odisha. He made several contributions to the Odisha Integrated Irrigated Agriculture Water Management Investment Program, which earned him recognition from the Engineering Chief Water Resources from Government of Odisha. So he's also serving as a visiting professor at College of Engineering and Technology and Odisha Computer Center. He's an empaneled resource person with the Department of Water Resources who trains the assistant executive engineers of Odisha State. In 2023, he was honored with the Gyan Puraskar Dynamic Process Award by the Global Scholar Foundation for his outstanding contribution to the academia. With nearly 2 decades of experience, Dr. Pathy specialized in GIS, remote sensing, land use planning, urban development, and disaster management. His dedication to teaching, research, and collaboration makes him an inspiring leader in this field. My dear participants, most of you are civil engineers. We have till yesterday we have seen so many topics on the civil engineering related areas. Now we have an eminent personality who is going to explain about this water resource side in collaboration and including like geospatial technologies and all. It is a very advanced field, what you can say. I hope you'll enjoy the session. Kindly please attend and hear this session, please. Now, sir, Dr. Ashish Chandra Pathy, sir, I welcome you for this online FDP. I'm very much thankful to you on behalf of JNTUA for giving us time and to be a part in this offline FDP, online FDP, sir. Thank you very much, sir. Now, over to you, sir. Please take over the mic, sir.
Thank you, sir. Thank you for inviting me to this particular FDP program, and a very good evening to all the participants who is attending the particular FDP program. That is, so today we'll discuss about the application of geospatial technology for disaster management. So in this session, we'll discuss about what is geospatial technology and what is in brief about the geospatial technology and what are the different applications uh, of the geospatial technology in disaster management. So I'm just showing my slide. So the slide is visible to all of you.
Yes, sir. Could you please hit on the presentation mode, sir? In slideshow.
That is visible, no?
Yes, sir. Yes, sir. Just I'm requesting to switch to slideshow, sir.
Sir?
Sir, could you please hit on a slideshow button? सर नीचे वो कॉर्नर पे एक बटन है ना सर, जूम बटन के बगल में, नीचे जूम बटन के बगल में सर, वो सर हिट, दैट्स वन सर, राइट सर.
Now it is visible, no?
No, could you please move slide sir? सर वो जूम बटन के बगल पे एक बटन है ना सर, उसको हिट करना है सर. हाँ, yeah, that one sir, that one, first one sir, immediate first one, yeah, that one, good sir. Could you please move the slide sir? Right sir, good sir. Thank you sir, thank you very much.
So we must discuss what is geospatial technologies. So it is a field where this field uses various tools like GIS, remote sensing, like GPS and ALMS, and other things are there like photogrammetry. So different tools the geospatial technology used for different types of applications. So we'll talk about disaster management here. So first of all, we should know about what geospatial technology is. He is Vikram S. Sarabhai, who is the father of Indian space program. So once he said we must be second to none in the applications of advanced technology to the real problems of the man's and society. So we must be fast. So geospatial in spatial technology, we must be fast in the world. So we generally we live in two worlds. That is, one is natural and one is man-made. Natural is what it is self-regulated, and man-made is what it is managed by the anthropogenic activities, and they are generally increasing in conflict. So we are evolving towards a more and human-controlled world. That is, there is growth of population, there is increasing consumption, and there is also changes in land use and land cover. So it leading to decreasing resources, natural areas, and diversity. and it generally creating problems in both the worlds. So our world is changing rapidly. So there is some maps is there where there is projected water scarcity in 2025 is shown in geospatial technology, and there is a huge amount of changes in forest covers occurred during the decades. Population also increasing, population density is also increasing throughout the world, and it is influenced by everything we do and also do not do. So in other words, we live in a changing world that is population, urbanization, globalization, economic development, environmental change, human conflicts, growing knowledge, advancing scientific and technology, which is increasing very complex, challenging and crowded. So to meet these challenges, we need to have a common vision, that is building a digital abstraction of the art. So we need better ways to represent it and understand it, also manage and communicate our world as a system. So it is an evolving system for measurement, monitoring, modeling, planning, decision making, management, and which affecting our planet's evolution. So for measuring, monitoring, and modeling, geoinformatics or geospatial technology, it provides a framework. Uh, so geospatial technology uses these tools like GIS, information and communication technology, location-based services, photogrammetry, total station, like remote sensing. Remotely sensed data is very useful data for GIS. One is GPS, where we are getting latitude and longitudinal value of a particular place, latitude, longitude, altitude, and also time also we are getting from GPS, and also definitely bandwidth, that is the maximum capacity of network or internet to transfer data, and ALTM, that is your leader, like light detection and ranging. Leader data also we are getting from the satellite. A total station is also a surveying instrument. So these are all, if we convert all these tools, we are getting geospatial technology. So in sometimes most of the tools are using for disaster management and all types of management we are working with. So defining when we are going to different types of geospatial technology, so all the related data generally uh, 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 captured in GIS. So GIS is a computer-based technology that captures, store, integrate, organize, and analyze and displaying geographically referenced information, which is the data generally related to location, that is spatially referenced location, latitude and longitudinal value. So GIS involving spatial and attribute information to act as a decision support tool. It keeps information in different layers and generates various combination patterning to the requirement of the decision making. So generally GIS involves spatial data that is related to the spatial location. We can say the location related to forest is located to urban areas, any type of objects you are identifying in the surface of the earth. So that is spatial data. So spatial data generally it is related to the location, and attribute information, that is the additional information about the spatial information, that is the non-spatial information or attribute data. So all the data we are getting from the different sources, and generally GIS is a system where all the data will be stored, and all the data is integrated and also organized in a GIS database, and it is displayed in a geographically referenced information. So these are all data. There is one is satellite data, aerial photographs, digital maps. Generally, we are getting from different offices, like temporal data sets. If map is generated earlier in that particular office, and other digital data if available in the particular area of interest where we are working with. So all other tabular information. So all the data is integrated into a particular system, that is GIS. So GIS is a major system where all the information, all the data is integrated, and the GIS is processed that particular data, and we are getting information like we are getting a topographical map or topo sheets as shown in the slide. So We are in the 5 decades of Indian space program. That is, one is application-driven program, that is self-reliance in building and launching satellites. We have 45 launch vehicle missions, the satellite launch vehicle missions like PSLV and GSLV, that is geosynchronous launch vehicle missions and polar satellite launch vehicle missions, and 74 spacecraft missions. So we have generally 2 types of satellites. One is communication satellite and another one is remote sensing satellite. So in communication for disaster monitoring, we are generally working with the communication satellite like INSAT, that is Indian National Satellite System. INSAT 3 is launched in 2003, like Kalpana, like INSAT 2E, INSAT 3, 3C, INSAT 3B, 3A. These are all successful communication satellites. That is now the space, and GSAT also, geosynchronous satellite, and these are all remote sensing satellite, that is starting from Aryabhatta. Now IRS series of satellite, that is Indian remote sensing satellite, and these are all missions like IRS missions. 1A is a mission 1A, 1B, 1C, 1D, like this, and 1A is a first mission which was successful, and after that IRS P3, that is P1, that is program P1, P2, P3. These are all IRS series of satellites where we are getting different remote sensing, remotely Earth observation photographs or images. So these are all communication and remote sensing satellite we are getting for disaster monitoring and management. This is our spaceport of India, that is in Sriharikota, where space generally the satellites launching vehicle station. This is Sriharikota. We know it is in Hyderabad. So this is your space technology application, that is communication satellite, as I have discussed earlier, that is INSAT or GSAT series of satellite. It is generally the application is on meteorology, radio, TV broadcast, and disaster warning. And the remote sensing satellite, that is Indian remote sensing series of satellites, it is generally for the natural resource monitoring and management. So the remote sensing is generally what we are talking about. We are getting remotely sensed data, that is satellite data or aerial photographs or drone related data. What data where remote means far off observation. Remote sensing is far off observation. That is, we are observing from a remotely remote areas. That is refers to gathering and processing of information about Earth's environment and its natural and cultural resources through aerial photography and satellite scanning. So generally, it needs the electromagnetic radiation to carry the information through sensors. So the output of the remote sensing system is usually an image representing the scene being observed. So we are generally 2 types of remote sensing system. One is passive remote sensing system and another one is active remote sensing system. So in passive remote sensing system, so generally the eyes generally passively senses the radiation reflected or emitted from the object. The sensing system depends on the external source of illumination. So the satellite is using the sun's energy to acquire different types of data. So in active remote sensing system, it provides its own source of illumination, like it uses the own source of light, that is your laser light. In night also, remote sensing satellite can acquire data. So it is very useful for disaster monitoring. In night also, we are this particular remote sensing using microwave remote sensing, microwave electromagnetic spectrum to acquire different types of data. So we are generally 2 types of remote sensing. One is airborne remote sensing, another one is spaceborne remote sensing. So in airborne remote sensing, generally aeroplane is taking photographs and sensors generally mounted on an aircraft. So its advantage is the capability of offering very high spatial resolution images, that is 20 centimeter or less resolution images or photographs we can get. We are also getting UAV, that is unmanned aerial vehicle, where we can get 20 centimeter or less spatial resolution data. So the disadvantage of this particular airborne remote sensing is a low coverage area and a high cost per unit area of ground coverage. So it is very costly data to acquire. So in space-borne remote sensing, generally sensors are mounted on a satellite orbiting the Earth. Generally two types of satellite orbits. One is geostationary satellite, another one is polar satellites. So in geostationary satellite, generally the satellite appears stationary with respect to the Earth's surface. Generally the particular satellite is placed above 36,000 kilometers from the Earth's surface. It is like this, like geosynchronous, like it is moving at the same rate of the um, uh, Earth. So communication satellites are geosynchronous orbit, that is Earth synchronous, moving at the same rate. This means that the satellite always stays over one spot on the Earth. The area on the Earth that it can see is called the satellite's footprint. So generally, geostationary satellites are generally, these are all communication satellite, always rotating according to the rotation of the Earth. So INSAT series of satellites, GSAT series of satellites, these are all geostationary satellite or geosynchronous satellite. So another one is near polar orbit satellite. A near polar orbit is one with the orbital plane inclined at a small angle with respect to the Earth's rotation axis. A satellite following a properly designed a near polar orbit passes close to the poles and is able to cover nearly the whole Earth surface in a repeat cycle. So Earth observation satellites usually follow the sun synchronous orbits. So it is following the sun. So sun synchronous orbits like this. So a polar orbit is a particular type of low orbit Earth orbit, that is the satellite travels at north-south direction rather than a more common east-west direction. So it generally captures photograph in different periods, that is repetitive coverage of the particular area of the surface of the Earth. So we can get the remote sensing satellite out of it. So different images in different time periods we can get from this particular satellite. So how remote sensing is taking photographs. So first, the energy source is your sun. So sun is the ultimate source of energy, and the energy generally travel through electromagnetic radiation. So EMR is the major thing that it is converted into an image. So first, electromagnetic radiation is interacted with the atmosphere, and some is reflected, some is emitted, and some is absorbed, and some is transmitted. And most of the portion is interacted with the target, that is your object. So the reflected energy and emitted energy generally received by the recorded by the sensor, and it is converted into a digital signal. So the digital signal then the sensor is the digital signal transmitted to the particular reception center. That is now the reception center in India is at Sadnagar, that is in Andhra Pradesh, Hyderabad, near to Hyderabad. So after the reception, after the electrical signal is received by the particular your antenna, it is converted into a disc-like device, and that particular signal is interpreted in the particular lab, a laboratory that is at NRSC, National Remote Sensing Center is there, at a National Remote Sensing Agency that is there in your Hyderabad. So all the interpretation like your geo rectification, all these things are done in at NRSC Hyderabad. So this is your solar energy. Some of the energy is reflected back, and reflected energy. So reflected energy is of two types. One is your thermal reflected thermal infrared, and another one is reflected infrared. So in thermal infrared, what we are getting is your emitted energy data, that is your temperature related data, and reflected energy data, what we are getting your remotely sensed earth observation or remotely sensed data. So this is your particular this is the particular process where the sensor is received the reflected energy and emitted energy, and all the data is is processed in a particular laboratory, and it can also produce hard copy maps, and um, then only we can analyze and model the particular data in a particular organization. So this is your panoramic view of our station at Sadhnagar, where this is the data receiving station. So finally, what we are getting an image. So image generally organized in a grid of columns and rows usually represents a geographical area. So it generally represents in pixels, that is pi into el, that is picture elements. These are all picture elements. So we're getting data like in a grid of columns and rows. So the reflected energy, the brightness characteristics of the image is captured by the particular sensor, and the reflected portion is converted into digital numbers, that is DN values of that particular numbers is there. So according to the brightness characteristics of the particular object, so the sensor detect different types of spectral reflectance, and accordingly different images are formed. So these are all the images generally of different resolution, that is one is spatial resolution, spectral resolution, and temporal resolution, radiometric resolution. The spatial resolution is the smallest object that a sensor can identify, that is spatial resolution. And spectral resolution, that is the number of bands used. They are like spectral bands. So we are using different electromagnetic spectrum, starting from gamma rays, X-rays, your um, visible bands, your ultraviolet rays, then your visible bands, then your microwave and radio wave. So we are generally in remote sensing, we are using some sorts of ultraviolet rays, and all portion of visible bands, and all portion of infrared and microwave. We are not using X-rays and gamma rays. So whatever the spectral bands are there, so different minimum number of, if there is more number of different bands we are getting, there is more spectral resolution. If there is minimum number of spectral bands, we are getting less spectral resolution on that particular sensor. Then temporal resolution, that is periodicity of data collection. So different in different time periods we are getting data. So that is one is radiometric resolution, that is quantization level of data, that is brightness characteristics of the data we are getting from the particular sensor. So one is your spatial spectral resolution, and another one is temporal resolution. So it has so different each sensor have different resolution capacity. So accordingly we are um, getting the satellite data. So these are some of the Indian Earth observation missions. That is Sun synchronous satellite, and another one is geostationary satellite. So starting from IRS 1A and 1B, in the year 1988, we are getting 72 meter spatial resolution data. That is pixel size of that particular image. And accordingly, in 1997, we are getting LEAS 3 and IRS P4, that is Ocean Color Monitor. And in 2003, we are getting resource chart, that is LEAS 3 and LEAS 4. LEAS 3 resolution is 23 meter, and LEAS 4 resolution is 5.8 meter resolution. So likewise, we are getting panchromatic images like Gatosat 1 and 2. Gatosat 1, that is 2.5 meter resolution, and Gatosat 2 is your like 60 centimeter resolution data we are getting. So now we are in the phase of Gatosat 3, that is high resolution satellite, that is in the space. So there are different types of geostationary satellite, that is your communication satellite, like INSAT 1D, 2A, that is INSAT 2E, Kalpana, INSAT 3A is there in the space. So these are our Indian imaging capability. So every so this is a 1 kilometer resolution satellite data. That is your that is every 30 minutes we are getting the particular image. Um, so this is generally used for the application of climate and weather. So this is a very important satellite that is used for climate and weather condition, and we are also taking use of the for disaster management. So this is 360-meter resolution data, that is every 2 days imaging, that is 1 in 250,000 scales. Generally, the application is ocean applications. And 188-meter resolution, that is every 5-day imaging, that is 1 in 250,000 scales. This particular image is used for the national surveys. And this is 23-meter resolution, that is every 22 days we are getting the image, that is 1 in 50,000 scales, that is detailed resources survey. This is a very important satellite, that is 5.23-meter registry satellite imagery. Now it is 24-meter resolution data, which is now freely available in the particular Google website you can get. So in 5.8-meter resolution, that is LIS 4, that is linear imaging and self-scanning. This is a particular image. This is also maybe available in the Google website. Some portion it is available, but you can, if you want all the portion of the particular image, you have to requisite to the NRSA, National Remote Sensing Agency, so that you can get the data. So it is a 5-day imaging data, that is 1 in 2500 scales. The large scale mapping, it has also stereo capability. So 3D mapping, you can also we can also do the 3D mapping, 3-dimensional figure mapping in this particular image. And this is 80 centimeter resolution data, that is local area imaging. It is also have the stereo capability. So generally, what can be seen from satellite images? So so you can see different cultivation like banana, maize, tobacco, chilies, cotton, paddy. So different by using different image interpretation techniques, we have differentiated different pixels. So this is you can identify different types of crops. One is this is salt affected area, and one is waterlogged area. You can see from the image. This is a pan and a particular multispectral scanner, and pan multispectral means different spectral band used in this particular image, list 3. And panchromatic image, that is a generally high resolution satellite image. Generally one particular visible band is used particular in panchromatic images, and this particular image is generally formed by the when we are merging this particular 2 images, then this particular images is formed. So another one is we can also see different types of rock types here. We can also interpret different types of rock types like sediments, sedimentary rocks or igneous rocks. We can also whether it is a metamorphic or sedimentary rocks, we can also differentiate. We can also differentiate, you can see the different structures like lineament or fault. Fault, fold, dike, you can also identify from the image. And you can also identify that is valley field with vegetation. So you can see different types of vegetation here, and black soil cover, salt affected land. So you can detect different types of features or objects from the satellite images. So one is hilly terrain with forest. So terrain data we can get from the different data is there, like Geospatial and SRTM data, like shuttle ladder topographic mission. We can get elevation data out of it. So you can easily get the elevation of a particular place. And agricultural lands, you can identify agricultural lands like delta, different river courses, coastline, mangrove forests, wetlands, and water turbidity. So we can also see different reservoir. So you can map a reservoir out of it, different types of river course, river configuration, flood plains, etc. So we are coming to the topic, that is disaster. That we know disaster is a natural or man-made hazard resulting in an event of substantial extent causing significant physical damage or destruction, that is loss of life or drastic change to the environment. So it is a phenomenon that can cause damage to life and property and destroy the economic, social, and cultural life. So generally we have two types of natural disaster. Two types of disaster. One is natural disaster and man-made disaster. You have also learned from the previous sessions, that is cyclone, volcanoes, floods, earthquakes, and man-made disasters like terrorism and war. So, what is disaster management? So, natural events cannot be prevented, but potential disasters can be managed to minimize loss of life through a four-part cycle of mitigation, preparedness, response, and recovery. So, first, in the mitigation phase or prevention phase, we are generally establishing the objective, what we're going to do, and then we are assess the risk, what is the risk prone area, um, and risk prevention and mitigation. And in preparedness and preparedness phase, we are generally emergency and evacuation. We are planning for emergency and evacuation routes, emergency teams and drills, like emergency response equipment. And in response phase, like rescue and relief salvage, immediate damage assessment, immediate protection of damaged heritage. And in recovery stage, we are recovery and rehabilitation, treatments, restoration, retrofitting, repair, and detailed damage assessment we are doing in recovery phase. So generally, it's a systematic process which aims to reduce the impact or consequences of any adverse event like flood, earthquake, disease, etc. So it is more than just response and relief. So hazard, we know it is a potential for a natural or human caused event with negative impacts or consequences. So another one is emergency. That is a situation generated by real occurrence and an event that requires immediate response or attention. So in disaster, so generally it's a natural or human caused event which causes intensive negative impact on people, goods, services, and environment. So I'm not going more detail into it. So we know that is risk is a potential or likelihood of an emergency to occur. For example, the risk of damage to a structure from an earthquake is high if it is built on or adjacent to an active earthquake fault. So risk can be determined as a product of hazard and vulnerability. That is, risk equals to hazard into vulnerability. So vulnerability is the extent to which a community structure, services, or environment is likely to be damaged or disrupted by the impact of a hazard. The vulnerability could be tangible or intangible. So what is the role of geospatial technology then? So when we are using geospatial technology, um, so we are in GIS generally, particularly, we are getting better data storage. So large amount of data we can store in a particular platform, that is geographical information system. So all the data, majority of many of data can be stored in GIS. We can it is better in data analysis. So um, 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 different types of data can be analyzed. So we are using different types of computer, starting from the supercomputer to microcomputer. So supercomputer generally they are using in NRSC. So many data can be analyzed in a particular system. So it is very handy in planning. We can generally create different types of layer, different type of database like land use database, geomorphology, lithology, and different type of database can be used in a particular platform, and it can be overlaid to one another for a handy for planning. So it is helpful for stakeholder and decision makers. So decision makers can take decision out of it. So by analyzing different type of database, and generally. It's a tool that allows users to create interactive queries. So different types of queries we can uh, create and analyze spatial information. We can edit data, maps, and present the results of all these operations. So GIS provides environment for effective and efficient storage and manipulation of remotely sensed data or other spatial and non-spatial data types for both scientific management and policy-oriented information. So the specific applications in risk assessment are hazard mapping. Generally, first what we do is that is mapping hazard prone area to show earthquake, floods, landslides, or fire. So these maps are generally used for warning system. And GIS application can be useful in the following activities, like to create hazard inventory maps and to locate critical facilities, create and manage associate related database and vulnerability assessment. So these are generally the major applications of GIS. So in disaster management, what GIS can do. So GIS is useful in helping with forward planning. It provides the framework for planners and disaster management to view spatial data by way of computer-based maps. So generally, spatial data we mean different types of data, like different features, like it can be road database, it can be river database, it can be a water body database, it can be a land use database, and specifically climate related database, climate and weather related database, that is generally with reference to the location. So in mitigation, what GIS can do, it representation of the high risk areas. So we can identify high risk areas. We can facilitate the implementation of necessary mechanism to lessen the impact. So by using different databases, we can implement different mechanism to lessen the impact of the particular disaster or hazard. So in preparedness planning, that is first is identification of the emergency areas, positions of related departments. By using GPS, um, we are generally create database about the department, like agencies, line departments, disaster related line departments, and human resources. And it is make it easier for security and shelters providers to plan the strategy. So it also answers that which to be based where and what phase of emergency we can use the data. And in response phase, we can provide accurate information on exact location of an emergency situation, time saving during the determination of trouble areas, that is quick response. Then it is used as an floor guide for evacuation routes by creating different types of road features, road database. And in recovery phase, there is mapping level of damage. What is the extent of damage in a particular area? We can map with the help of the satellite imagery, and the information related to disrupted infrastructure, number of person died, or injured. So for emergency shelters, GIS can be used by shelter operators to capture specific personal detail of the person being housed at the shelters. It would make it possible to assess the number of needed shelters and the structure of their suffering population, like children, adults, disabled, etc. By creating different, by integrating different population database into the particular village or block layers, so we can create different types of so how many population can be adjusted in the shelter, we can assess. Then for GIS and distribution relief in affected areas during and after disaster, food drops is always likely to take place. This process can be helped with the GIS, as maps can be generated which identify the specific areas with clusters of victims are located and the unique need of persons within these clusters. So the data is gathered for the analysis and to assess the need of activities and actions before, during, and after the disaster. By the use of this data, maps of most vulnerable areas can be produced, and those areas can be highlighted which are most prone to disaster. So what is the basic requirement for disaster, basic data requirement for disaster management? That is, it is coming from different scientific disciplines and should be integrated into the system. Data on the disaster phenomena like landslides, flood, earthquakes, their location, frequency, magnitudes, etc. can be gathered. Data on the environment in which the disaster events might take place, like topography. So topography data we can generate by the use of elevation data, by the microwave remote sensing data, like radar and lidar data, radio detection and ranging, and light detection and ranging. So the data is available like SITM and geology data can be generated. That is, geological structure can be generated from different kinds of data. Geomorphology is also useful. Soil data, hydrology data, land use data, vegetation data can be gathered. Data on the elements that might be destroyed if the event takes place, like infrastructure data, settlement data, population data, socioeconomic data, etc., can be gathered in GIS for disaster management. So data on the emergency relief sources such as hospitals, locations, fire brigades, police stations, where resources can be generated. So these all data will be required for disaster management. Um, if we are analyzing the role of remote sensing in cyclone, so first we should go for the risk modeling. What is the probable risk areas? So in the mitigation phase, we have to go for the risk areas and vulnerability analysis. And vulnerability area mapping we can done through GIS. And in preparedness phase, in early warning, we can use the data your insert data and your Corpana data. Generally, we are using INSAT data, Indian National Satellite System data. We are using for early warning and long range climate modeling. So, accordingly, by analyzing different climate related data, temporal climate related data, we can use we can model the long range climate modeling. And in the rescue phase, we can identify escape routes like and impact assessment also. And recovery phase damage assessment can be done after the disaster, and also spatial planning. So generally we are using Kalpana 1, insert data, radar, Meteosat, Landsat, IRS series of satellite. So these are all data is required for all these particular disaster management cycle of the cyclone. So in earthquake, we can also mm, in mitigation phase, we can assess the building stocks. What are the generally to identify, to analyze the building stock vulnerability. So, what are the building? The goal is to strengthen or retrofit building to minimize the damage. So, measuring strain accumulation, that is in preparedness planning, where there is strain or coastal deformation mapping. If there is in tectonic forces, if there is in coastal change is there, when if there is change in the crust due to tectonic forces, so we can before that we can map the coastal deformation. Then in the rescue phase, it is for planning routes for search and rescue. We can generate the planning routes by use of GIS technology. And in recovery phase, damage assessment can be done. We can identify sites of rehabilitation also by using different database. And the satellite generally used is Pulsar, Iconos, Spot, Indian remote sensing satellite. So these are all for remote earthquake. So generally in the first phase, we are generating a geological map, geological structure map like lineaments in mitigation and preparedness phase, where there is fault, where there is fault. So we need to assess all these things before the disaster. And in the rescue phase, in the recovery phase, we can assess damage assessment. So the World Agency of Planetary Monitoring Earthquake Risk Reduction uses remote sensing to improve knowledge of building stocks. For example, the number and weight of buildings, height of the buildings. High resolution imagery can also used help hazard mapping to guide building codes and disaster preparedness strategies. So in floods also, we can map different flood prone areas, like delineating flood plains. We can delineate from the different satellite imagery like LEAS-4 or high resolution satellite images. We can also do the land use mapping for flood, to what extent, if flood occurs, to what extent the flood will inundated. Then in preparedness phase, we can detect the fraud detection by analyzing different rainfall and runoff characteristics of the particular region. Early warning in preparedness phase, we can The remote sensing can do early warning, and rainfall mapping. It is also in preparedness phase. So in rescue phase, that is evacuation planning and damage assessment can be done. In recovery phase, also damage assessment, and generally we are monitoring different rainfall by using AMSAR data and Kalpana data. So this is a Sentinel Asia is a generally it's a project that is a team of 51 organizations from 18 countries that delivers remote sensing data via the internet as easy to interpret information for both early warning and flood damage assessment across Asia. So this particular project generally remote sensing data for the early warning and flood damage assessment. So it uses Dartmouth flood observatory river watch flood detection and measurement system based on AMSRE data to map flood hazards and warn disaster management managers and residents in flood prone areas where rivers are likely to burst their banks. So this is a particular photograph of floods in Assam and in Uttarakhand. So in other disasters, we are also in Dortmund area. What we're doing is we are modeling. Risk modeling has been done by analyzing different rainfall and land use characteristics of the particular region. And in preparedness phase, we are forecasting. Weather forecasting can be done, and vegetation monitoring. We are using NDVI, National Differential Vegetation Index, for health monitoring of the vegetation. And crop water requirement mapping, early warning also there in the preparedness phase. In recovery phase, we are monitoring vegetation, whether the health of the vegetation is good or not, and damage assessment. Then in rescue, we are informing drought mitigation. In satellites, generally AVHs are Moody's and spots data are generally used for this drought assessment. And in volcano also, risk modeling by using different digital elevation data, where risk modeling can be done and hazard mapping can be done. And in preparedness space, emission monitoring by thermal infrared, like your Landsat data. In Landsat 8, Landsat OLI data, there is thermal remote sensing data. We can monitor the emissions of the volcano. And in recovery phase, we can map the mapping lava flows and evacuation planning. And in rescue phase, that is damage assessment and spatial planning can be done in rescue phase by mapping the volcano prone areas. Generally, Moody's, AVHR, and Hyperion satellites are used. And in the fire mapping, we are mapping fire prone areas by different image interpretation techniques and corresponding to field verification. We are mapping fire prone areas, and also risk modeling can be done through remote sensing and GIS technique. And in preparedness phase, what we are doing, fire detection and predicting and direction of fire can be done, and early warning for preparedness phase can be done through GIS. And in recovery phase, that is coordinating and firefighting efforts that can be done in recovery phase. And in rescue phase, that is damage assessment, and generally Moody's, Sentinel Asia, and AFIS data are used. And in landslide mapping, generally we are using landslide hazard mapping by using digital elevation models. We are generally in preparedness planning, rainfall monitoring can be done, and slope stability and instability is done in the preparedness planning, where there is stable slope or unstable slope. And in recovery phase, we are mapping affected areas. And in rescue phase, damage assessment, spatial planning, suggesting management practices. These are done in rescue phase. So generally, Pulsar, Iconos, INSAR, Spot, and IRS series of satellites are used for the particular landslide management. And these are some of the case studies. That is use of remote sensing and GIS in Phylline cyclone, that is in Odisha. So in 7th October, generally IMD, Indian Meteorological Department, received information from Kalpana 1, that is OceanSat and INSAT 3 Doppler radars deployed at vulnerable places with overlap sensors in the sea and through the ships about a cyclone forming in the Gulf between Andaman Nicobar and Thailand named Hylin. The first IMD generally received information from the satellite that there will be there a cyclone is developed in the particular area in Andaman and Nicobar area. And in 8th October, IMD confirmed cyclone formation. You can see the satellite images, the cyclone formation here, and predicted it as a severe cyclone, and its effects would be felt from Kalingapatnam in Andhra Pradesh to Paradip in Odisha, and that is would probably fast strike the port of Gopalpur in Ganjam district at about 5 p.m. on 12th October. The wind speed could touch 200 km per hour. 10th October in 2013, you can see IMD prediction of a severe cyclone. The eye of the cyclone is here and was converted to a very severe cyclonic storm with wind speeds up to 220 km. The US Navy's Joint Typhoon Warning Center predicted it would have wind speeds up to 315 km per hour. So in 12th October, you can see the very severe cyclone storm had its landfall at Gopalpur port at about 9 p.m. With a wind speed of 200 km per hour. So this is the different images of the particular satellite images of the cyclone moving from one place to another. That is from 7th October to 12th October. So early warning can be done through particular images. This is a mitigation phase. That is this is a case study of Odisha. That is first is risk modeling and vulnerability analysis. That is strengthening of for the risk modeling and vulnerability analysis, we map different hazard-prone areas. Multi-hazard map generally generated from previous data. By taking previous data, multi-hazard map and vulnerable map has been generated, and we have strengthened the EWS system, that is early warning system. Generally, the Department of Water Resources is working with the Water Resources Odisha. Is working with the rainfall data analysis, and IMD is working with the early warning system, that is regional meteorological center Bhubaneswar. So we have strengthened the EWS in this particular particular cyclone. So disaster response infrastructure, disaster drills has been undertaken in mitigation phase. So preparedness phase, that is early warning system. We have constant updates from ISRO and IMD. One day 15 minutes data we can get from the ISRO, and distribution of satellite phones, VHF and ham radio to DMs. Like we have distributed satellite phones to the district magistrate videos and surveillance, and also we have given them VHF, that is very high frequency and home radios, where satellite phones will not be work. The VHF and ham radio will be work, and the mass evacuation on the basis of cyclone path over the state. This is in the particular preparedness phase. In the response phase, we have different Google Crisil map and Google People Finder. And ODRAF and NDRF deployment. Have deployed ODRAF, that is Odisha Risk Action Force, and NDRF for response in response phase, and in recovery phase, that is relief operation coordinated by Navy and Air Force, and disaster assessment has been done, and logistic coordinated with central operated units and spatial planning. So generally, Odisha in this phase, but in this particular phase, we have 0 casualties in this particular disaster management cycle. So this is a particular flood due to cyclone, that is it's a severe cyclone in 29th October 1919 off coast of Odisha. You can see the different type of satellite images, different period. That is in 1999. This is you can see the pre-cyclone phase, and this is the post-cyclone phase, that is on 5th November 1999. So after a month, you can see what is the flood situation after the cyclone. Now you can interpret different flood-prone area, flood-inundated area from this particular satellite imagery. So this is we have also developed a disaster management system for Odisha. So for that we have generated different GIS databases, that is a land use database, geomorphology, lithology, structure like geological structure, soil data, administrative data, district maps, block data, village data, infrastructure, and all these things have been there with the internet. So all these data can be these are all different satellite images. All the data can be overlaid. So the integration we can overlay. We can also integrate flood layer into the particular in different layers according to your requirement. You can put different layers into the flood layer, so we can see different types of damages, what damages are how the particular disaster is impacted to the particular area. So this is your flood inundated area. We can see from this map. So in post disaster assessment, we can do by the use of remote sensing data. So this is the multi-hazard map. It has been prepared in the preparedness phase. So these are all different types of wind and cyclone damage risk zone. So it has been prepared before the cyclone. This is a depression track, that is a cyclone that is developed in September 2008 at Odisha. So this is the depression track in different time periods. So the track has been done by the use of geographical information system. So so, um, so you can do the early warning system, and the so generally we have developed this particular depression tag for the early warning system, early warning to the people of Odisha. So this is the flood affected districts after the disaster um, in 2008. So this is your ISO height has generated by the help of the GIS, where you can see different rainfall in different dates, the amount of rainfall. So in these are all river basins. So we have generated the ISO height map, that is equal rainfall map. So all the starting from the 10th, 11 October to 13th October. So we are on, we are on the process of real time warning to the people of Odisha. So this is your the storm event, that is the track of Hudur, that is um, created by the use of GIS, and this is your flood inundated area. So you can see that is 5 August 2014. These are all flood inundated area. So these are all areas we can map from the GIS. This is a vulnerable location due to flood. In various vulnerable locations has been mapped in different areas of Odisha. So you can see this is the particular image of 1988, and this is the image of 1993. So this particular area is inundated and it is a flood prone area. You can see the flood is there in the particular image. So we can map here how much area is affected out of the flood, and we can also superimpose different database like population database like how much population is affected due to flood, and how much infrastructure has been damaged due to the flood. If there is database of infrastructures, we have database of the infrastructure is there. Then this is the inundation mapping. This is also area of Odisha. That is inundation recession during 2 to 13 November 1999. So where you can see in different time periods how a flood is inundated and how it is receding back. This is also flood inundated areas of the particular Bhadrak district of Odisha. So it can also map from the particular satellite image. This is the flood waters. This is the satellite image, that is list for satellite image. You can see here that is these are all flood waters. So you can map how much area is affected out of it. These are all flood inundated area. So most of the area of the Bhadrak district of Odisha has been affected by flood in 8 July 2007. These are all. This is a image of tsunami that is part of Chennai city. You can see here how tsunami is affecting the particular coast of Chennai. And this is the post-tsunami scenario of Nagapattinam, Tamil Nadu. You can map different tsunami-affected area, so you can map out of it. So this is a particular satellite imagery. That is a high-resolution satellite imagery, Cartosat 2 satellite imagery. So we can map the tsunami-prone areas. So this is also how Japan tsunami Fukushima nuclear reactor has been affected. This is a particular image of 2007 and 2011. So you can see how the nuclear reactor is affected. Here you can see the nuclear reactor is here, but it has been affected by a tsunami here. So we can map those areas out of it. So this is the aerial data of damage assessment. So we can assess the damage by the particular images. So how many of infrastructures has been affected out of affected in the particular area. This is a part of Bhuj. This is the aftermath of the earthquake. And this is a barren island volcano was seen by IRIS P6 IOS data. That is Indian remote sensing satellite. That is program 6. IOS data, that is advanced wide field sensor data with RGB 432. This is your pre-eruption data. That is a barren island that is in Andaman Nicobar. A barren island. You can see the post eruption. This is the pre-eruption phase. So you can see different types of very high temperature anomaly. So what is the temperature? You can also measure from the thermal the satellite the sensor where thermal band is there. You can also measure the particular temperature of a particular place. And this is the plume area. You can map the plume out of it. So this is the volcanic eruption, and we can see it in 3D models. So this is your 3D view of the volcano. Directly we are generating 3D view out of the satellite imagery. So this is your real picture, and this is your satellite imagery. So you can map the volcano situation during and after the disaster also. Then this is your forest fire. So in India, there is 44 million hectare, that is 65% deciduous forest of India. 67.5 million hectare forest coverage prone to forest fires every year. So annual expenditure for conventional forest fire patrolling and combating, that is 75 crores. So we are generally the annual expenditure is 75 crores for forest fire detection, and the annual estimated loss is around 400 crores. That is the reports of Minister of Environment and Forest. So huge expenditure has been done for forest fire mapping. Watch report on large-scale burning in different parts of the country. Made studies conducted at the critical protected areas on pilot basis. Results were submitted within 1 day from the reception of satellite data. So this is a Rajiv Gandhi National Park and Bandipur Tiger Reserve and Mudumolai Wildlife Sanctuary. So you can see the forest fire. You can see the forest fire here, and you can also map the. We can assess the forest fire here. So this is the situation, that is active fire locations. So you can see in 2003 this is the particular satellite image, and in 2004 you can see the forest fire location has been identified. Active fire location. These are all active fire locations. And 2024 in 26th of February, you can see these are all active fire locations. And in 9th March 2004, you can see these are all vulnerability. We can it has been identified the vulnerability areas of the forest fire, and this is for 7th April 2004. So we have Indian Forest Fire Response and Assessment System. So this particular system has been developed by Government of India, and it used the application of RS and GIS, and different data products, remote sensing data products are being used for this particular assessing forest fire. And you can see these are all forest fire areas. That is the image. You can identify the forest fire areas, and we can go further management. And this is a particular pre and post satellite image for Kedarnath Valley. There is Kedarnath flood area has been identified. That is the water level. You can see here. You can see the water level is increased. So you can map the particular area for flood area mapping. And so this is a satellite image of Kedarnath. This is the pre imagery, and this is the post imagery. This is the in the post imagery you can see the flood prone areas. So we can map this particular area out of it. This is the Cartosat data of 2011. That is of Cartosat 2. That is 2.5 meter resolution data. It is 2011, and it is for 2013. And you can see the disaster takes place. This is before the disaster and after the disaster. So how satellite imagery you can see. So this is you can do done by the image interpretation technique. So you have to interpret the technique. You have to know the interpretation technique, so that you can map the particular flood prone area. And this is also before the disaster and after the disaster. And in the conclusion, so generally we can say natural hazards are an inevitable occurrence which has never and will never be in control of humans. Humans can only try their best to prevent it becoming a disaster. So geospatial technology can play a very important role in this endeavor, and hence preventing the loss of millions and innocent lives and billions of dollars of property. So it is highly prerogative that we must focus remote sensing methods more on mitigation and preparedness. So we have to focus on mitigation preparedness rather than rescue, as it is rightly said, prevention is better than cure. So thank you all. If there is any question, you can ask.
Raghu Babu sir, are you there?
Hello. Yes.
Sir, 1 minute, sir. We'll just all participants have question. I request all the participants, if you have any queries, please post. Sir, there is one question from Nagarajan.
Yes.
Sir, how do you ensure the continuous updating and maintenance of geospatial data sets, especially during long duration or ongoing disasters?
Again, sir.
Sir, I repeat, how do you ensure the continuous updating and maintenance of geospatial data sets, especially during long duration or ongoing disasters?
Yes, we have to create before the disaster occurs. You have to first you have to develop the different GIS database. So different GIS layer you have to develop first. So for remote sensing data, for the real-time monitoring, you have to requisite to the National Remote Sensing Center or NRSC and also ISRO. So there is you cannot say, but different satellite imagery is available, and if there is no data, remote sensing data is not available, you have to requisite to the NRSC. And first of all, you have to develop a GIS database, like your land use database, land use and land cover database, like your road database, like your river database. So all the database should be there, like your population database, village boundary should be there, block boundary should be there, district boundary should be there. So you have to generate different types of database before the disaster management. So disaster management, if you are going for a particular place, like I have shown you the Bhadrak district. So you have to develop different layers, like different database you have to develop.
Yeah. Um, is there any questions from participants? Hello.
So one question is there, for post disaster management, what geospatial technology can do?
Yeah, sir. There is a question from Nagarajan.
Huh. So for post disaster management, first of all, if we are talking about flood management, so for rescue, you have to develop, you have with you the road database. So you can, your road database should be there, your shelter database should be there, so they can be evacuated easily to their particular shelter. And also you can do your damage assessment. So damage assessment is there, that satellite imagery is required. So you need the satellite imagery from NRSC or ISRO. So by interpreting your satellite imagery, you can assess your damage. What is the infrastructure is damaged, or what is how much population is affected.
Yeah. Yes. Is there any question from participants? Right. If dear participants, if you have any questions, please you can mail to Pathy sir. Sir will answer for sure. With this, I would like to conclude this on behalf of organizing committee and the participants of this 6 days online ATAL FDP. I would like to extend my heartfelt thanks for your enlightening session on remote sensing, sir. Really, we inspired by your contribution, which played a significant role in the success of our program, sir. Thank you very much. Thank you for your time. Thank you for being with us. Thank you very much, sir. Thank you.
Thank you, sir.
Yeah. Thank you once again very
Now,
much, sir, Pathy sir, for your enlightening lecture. So once again, thank you very much for sparing your valuable time and participating in this online FDP. Thank you very much, sir.
Thank you, sir. Namaskar.
thank you. Sir, now
Raghu?
I will get in touch with Ramesh Naidu, sir. Please give
Yeah.
2 minutes time to me.
Ramesh Naidu garu unnara, sir? Are you there, sir?
Sir, I will call to him, sir. Actually, the actual time is 7:30, sir. That's why sir will be joined a bit later.
I know. If
I
he's
will
there, we
contact.
can start immediately.
Yeah, sir. I will contact him, sir. Meanwhile, I will post my I will post a feedback of session 9. The participants can fill it. Dear participants, Professor Ramesh Naidu will be joining in 2 minutes. Meanwhile, I am requesting you all participants, please fill the Google form, which is placed in a chat box.
Raghubabu sir,
Yes, Yogi.
sir, Ramesh Naidu sir has joined.
Yeah. Sir, good evening, sir.
Raghu,
Sir, Ramesh Naidu, sir, join ayyaranta, sir.
వచ్చారా సార్ వచ్చారా?
Yes, sir. Ramesh Naidu, sir, are you there?
సార్ రమేష్ సార్?
Am I audible?
Yes, sir. Audible, sir.
Yes, sir.
Oh, 2 minutes, sir. Just I'll give a brief biodata. How are you, sir?
Yeah, fine, sir. How are you? Thank you.
Thank you for very much for sparing your valuable time at this hour, sir. 7:30. Really appreciate it, sir. Thank you.
sir.
Yeah. So, my dear participants, the second session of today's is application of drones in disaster management. The resource person is Dr. C.H. Ramesh Naidu Garu. So, Dr. Naidu Garu did his MTech from Andhra University in geoengineering and PhD water resource and GS from J2H Hyderabad. Is having nearly 20 years industry experience. That is very important here. And 9.5 teaching and research and consultancy expert. Is a professor and over 20 years experience in water resource engineering, remote sensing, GIS, survey, geomechanics, and environmental engineering, and commitment to interdisciplinary research and education, leveraging extensive industry and academic background for leading in the engineering, geospatial, and research. He promoted the integration of advanced GIS and remote sensing across the state, and also he was involved in Asian Bank projects, JICA, UNDIP, NHIA, JNNRUM, CWC, CPCB, GHS, GVMC, and MOHUPA. Is having a MOU with leading civil engineering consultants such as RV Associates, Hyderabad, and Genstu Consultants. So his biodata is very big. He worked for the team leader for work all back funds also. So complete like that, he's having 50 plus consulting projects. He authored 35 plus research papers, expertise in organizing seminars, workshops, conferences, and is a coordinator for ISRO outreach training programs for advanced remote sensing education to students and professionals. Is a coordinated center of excellence in drones, IoT, and geometric, fostering students' involvement in multidisciplinary and cutting-edge technologies. He is a member to various societies like Indian Society for Hydraulics, ISSR, ISG, INCA, IWS, and Institute of Engineers and other studies. Is a proficiency in ArcGIS, QGIS, GRAS, ERDAS, and Pix4MD. And so he's having lot of experience in this water, severe, and flood modeling, and is taking the advanced topic where our state is also discussing about drone technology. Okay, and one important thing is in industry, he worked as a associate vice president in RV Associates. That is a very great, like going in such a high position, and then 2015 to 2005 to 2015. That is almost 10 years he was a vice president, and 2015 he was a professor till date. It's a very big biodata he's having. Like I skipped many things, sir, because of lack of time. Sorry for that one. I hope, my dear participants, this drone is one of the important topic. Like even our honorable vice CM Garu is also informing and encouraging this drone technology. So it will be very useful to you to participate, I mean, to encourage your students also in this drone technology, please. And that too, it is related to disaster management. Sir Ramesh, sir, I once again thank you very much and welcome you to this JNTU ATAL online FDP. Thank you once again for sparing your valuable time. Over to you, sir, please.
Thank you, sir. Thank you for introducing me to the participants. And first of all, I would like to congratulate Professor Dr. Sasidhar and team for successfully organizing this online 6 days FDP on emerging trends in civil engineering for disaster management. And also, I would like to say thanks to Dr. China Venkat and organizing team for asking me to present a lecture in this program. And my today's topic is, shall I share this, Dr. Raghu? Yeah. Just a minute. Can you switch on to me for sharing my PPT?
Yogi, could you please allow Professor Ramesh sir?
Sir, you can share your screen, sir. No issues. You can directly share your screen, sir.
Yeah, is it visible now?
Yes, sir,
Yes,
it's
sir.
working.
Yeah. So thank you very much, sir. My today's topic is applications of drones in disaster management with a special focus on disaster mapping. And we all know that maps are useful for indispensable tool, essential for planning and designing of civil engineering infrastructure. And when it comes to planning stage, usually we use small scale maps. And when it comes to design stage, usually we use large scale maps. Similarly, the
Ramesh
maps,
sir.
yeah,
Sir, Ramesh sir.
yeah, please,
Could you please switch on presentation mode, sir?
1 minute. Am I audible? Right
No,
now?
you are audible, sir. Please open your presentation.
Yeah, it is already open previously.
No, sir. Your presentation is not open.
1 minute.
PPT, sir. Your PPT.
I'll just log in. Am I audible? Am I audible?
You are audible, sir. You are audible, sir.
I'm sharing the
Yes,
presentation.
sir. You are audible, sir.
Yeah. Presentation is visible. Is my presentation is visible?
Sir, share your screen, sir. Share your screen.
Is it visible?
Yeah, sir. Yeah, sir. It's working, sir.
Yeah.
Sir, now your mail is opened, sir. Now please open your presentation, sir.
Presentation is already opened. My PPT is visible now.
Sir, it's better. Actually, మీరు ఎప్పుడైతే ప్రెజెంటేషన్ నవ్ అని కొట్టారో అప్పుడు షేర్ యువర్ ఎంటైర్ స్క్రీన్ అని ట్యాబ్ ఉంటుంది సార్. యూ నీడ్ టు క్లిక్ ఆన్ ఇట్. Now, please stop your presentation, sir. Please stop your sharing, sir.
Okay. Stop sharing.
Yeah. Now, click on present now, sir. Click on the tab button present now.
Yeah, present now.
Now, present your entire screen.
Okay. And okay.
Yeah. Yeah. Now your yeah, good, sir.
Is it opening?
Yeah. Now, yeah. Super, sir. Right.
Shall I start now?
Yeah, good, sir. Great, great. Thank you very much, sir.
See, my today's topic is applications of drones in disaster management with a special focus on disaster mapping. And as you all know that maps are very much useful and indispensable tool for civil engineering, planning civil engineering infrastructure. Even in the stages of design also, the maps are very much useful. But there is a small difference. We use small scale maps for planning stage as well as and also we use large scale maps for designing the infrastructure in the stage of designs and all. And similarly, the maps are also useful for disaster management. And sometimes we may use small scale maps, sometimes we may use large scale maps for disaster management. And one more thing is, we all know that the maps are classified into special purpose maps and general purpose maps. When it comes to general purpose maps, for example, the maps that are available in Uber and Ola are general purpose maps available for everyone. And when it comes to special purpose maps, disaster maps are special purpose maps where we can use maps for disaster management. And another one is there is a disturbance. There is a disturbance here.
Could you please mute all the participants?
Sir, you can. Sir, you can.
Yeah. So this is my presentation. Usually there are 4 sessions. The first session is the overview of disaster mapping. I'll quickly slide through all these first session slides, and the second session and third session usually involves with technical jargon, how we can manage maps with drones using drone survey as well as photogrammetry techniques, and with a lot of technical jargon, and it will take a lot of time. Even second and third session also will take a lot of time. And the final session is also a general session where we can finish it very fast. Okay. So when it comes to key elements of disaster map, hazard information, type, extent, severity, historical data will be available in the hazard maps. Usually these hazard maps are prepared for different disasters, very specific to disasters only. Let's say if the disaster is floods, then the flood hazard map will be prepared. If the disasters are earthquakes, earthquake hazard maps will be available, and we can prepare earthquake maps separately. And if the disasters are landslides, the landslides hazard maps can be prepared. Okay. So similarly, the maps will represent with all the details like population, critical infrastructure, economic assets, and including topographical features. Very important. This is elevation and terrain, water bodies, and all these features should be represented in every disaster map. Land use and land cover is also very important. It includes urban and rural areas, vegetation, and infrastructure and logistics. Transportation network is also a key feature for disaster management. And socioeconomic data also sometimes will help you to manage the disasters efficiently. And real-time data, weather conditions, disaster progression, on all this information can be represented in the form of a map. Emergency resources are also very important because evacuation routes, resource distribution points, and all these features are nothing but the elements that we have to represent on a disaster map. And communication, it includes communication networks, legal and administrative boundaries. So all these elements are very important for preparation of a disaster map. And disaster map should contain most of these elements. So the advantage with these disaster maps, with all the key elements that are there in the previous slide, provides the foundational data for disaster management and identification of vulnerable areas for disaster management and identification of critical infrastructure for disaster management and enhance preparedness for disaster management and optimize resource allocation. This is also very important for public as well as for government agencies, like those who are working under disaster response teams and all, and support recovery efforts also, and inform long-term recovery and reconstruction strategies. These are the advantages if we have a disaster map for disaster management. And why disaster map? Risk assessment can be assessed, the risk can be assessed, and we can also, the preparedness and mitigation is also possible. Emergency response is also possible. Land use and land cover, urban and rural areas, vegetation, and recovery and reconstruction is also possible after the disaster. And policy and planning, very important for ministries who are working under Ministry of Defense and Ministry of Home. And insurance and finance planning, that is also very important. If something happens due to disasters and all, the government has to plan the insurance. And scientific research, for the research community also, these disaster maps are very much useful. And when it comes to present status of disaster mapping in India, National Disaster Management Authority uses GIS and remote sensing for hazard zonation and risk assessment. Usually, the present technology that is available, remote sensing, usually these drones are also comes under remote sensing technology only. And Indian Space Research Organization, ISRO, provides satellite imagery. So they have a very good support. They also give very good support for these disaster management agencies for providing real-time satellite imagery for disaster management. And National Institute of Disaster Management, this also one of the key agency, collaborates with various agencies to develop and refine disaster maps and models. And state disaster management authorities, SDMAs, and who works under state departments, state governments. And Bhuvan portal is one of the portal. Most of the remote sensing experts are knew about this Bhuvan portal. It includes GIS-based disaster management support, offering real-time data and maps. National Disaster Response Force, NDRF, uses disaster maps for planning and executing rescue and relief operations. And the vulnerability of Atlas of India, prepared by the Building Materials and Technology Promotion Council under the Ministry of Housing and Urban Affairs, Government of India, includes maps at various scales to assess and visualize the vulnerability of different regions to various natural hazards. So they have prepared hazard maps, vulnerability Atlas of India for large scale as well as small scale maps to represent the entire India, to represent state-wise, to represent district-wise, as well as vulnerability Atlas of India serves as a critical resource for identifying and mitigating risks associated with natural hazards, helping to build safer and more resilient communities across India. And these are the sample hazard maps that we can see prepared by the BMTPC. So one is earthquake hazard map, another one is flood hazard map. So, and this one is landslide incidents map, and this one is wind hazard map. These are all very small scale maps, like 1:1 million, 10 million scale maps, which represents entire India in the form of a map with all the details of the hazards. Okay. So, but sometimes we need to prepare large scale maps also, and that is actually the actual topic of today's hazard map preparation. My topic is mostly on working on large scale maps for detailed management of disasters. And several areas where disaster mapping in India can be improved is enhanced data integration. Advanced technologies are already available. Capacity building and training, policy and regulatory framework, public-private partnerships, infrastructure and resources, community involvement. At enhanced data integration, usually many departments have many maps generated by using different surveys and all. So the integration, they need to share the data between department to department for integrating the maps to prepare disaster hazard maps. And traditional surveying, methods of surveying and mapping the earth. This is usually the very basics of preparing, how to prepare maps and all. So we can prepare maps using traditional surveying techniques as well as remote sensing techniques also. So traditional surveying uses theodolites, total stations, DGPS, GPS, and GNSS satellites. GNSS and DGPS is different. GPS is global positioning system, whereas GNSS is global navigation satellite system. So there are the difference is GPS constellates with less number of satellites, whereas GNSS constellation is more number of satellites by various countries. So GNSS system is more accurate than GPS and DGPS. When it comes to remote sensing, satellites, aircrafts, and drones. Okay, so when you survey the area, Earth, using satellites, using aircrafts, using drones, we can prepare maps from these images: satellite images, aircraft, aerial photographs, and drone images. And similarity between the traditional surveying and remote sensing. When it comes to producing maps using traditional survey instruments and remote sensing surveys involves distinct methodologies, tools, and technologies. Both approaches aim to create accurate representation of Earth's surface, but differ significantly in their process and applications. And similarities like objective, both methods aims to produce accurate maps and topographic representation of a given area. And data processing, both require data processing. See, when we use traditional methods to observe the Earth, the recordings needs to be downloaded in a computer system, and we need to process the data. Similarly, when it comes to drone surveying or remote sensing surveys, we need to download the images to the computer system and process the images using a software. So data processing is important for both the methods. And accuracy, both can achieve high accuracy, though the means to achieve it vary. Applications used in various fields such as civil engineering, urban planning, disaster management, environmental monitoring, and resource management. And both the methods, using both the methods, preparation of maps, the maps can be used for various applications. And data integration, often data from both methods are integrated to enhance map accuracy and detail. And you can see the satellite, aircraft, and drone and traditional surveys. Satellites are usually one platform in remote sensing, and aircraft and drone is also comes under remote sensing only. This one is spaceborne and another one is airborne platform. And aircraft and drone are airborne platforms, and satellites are spaceborne platform. And traditional surveys are on ground. We need to use instruments to prepare the maps, survey the area, and prepare the maps. So the similarity is download images to the computer system. Here also download images to the computer system and download data to computer system. And after that, the processing of data, once you download from the sensors or cameras, and then here also the processing with using CAD or GIS software, so that once you process the maps or images. So post-processing and pre-processing techniques you need to adopt with various softwares and digitize. And after that, especially for the remote sensing techniques, these two methods, you need to digitize and create layers in the form of maps. And here also you need to process the layers that are captured from the traditional surveys. And you can prepare 2D and 3D maps. Here also you can prepare 2D and 3D maps and 2D and 3D maps, both digital and analog. Analysis for making decisions. So after preparation of the maps, obviously to make decisions, we can use those maps either in disaster management or in any other application. So this is what exactly the workflow between the remote sensing platform methods and traditional surveying methods. And when it comes to map scale, GSD, and resolution, these are the key terminology that we need to understand before preparation of the maps by any methods. Okay, So map scale ratio indicating the relationship between distances on the map and the ground. Large scale maps show more details over smaller areas. Okay. So large scale maps are nothing but it shows more details compared to small scale maps within a small area. Okay, so that is the difference between large scale and small scale map. And image GSD measures the ground distance covered by each pixel in an image. Usually, when it comes to map, we talk about large scale, we talk about scale, whether it is large scale or small scale. But when it comes to image, we talk about resolution or GSD. Okay, so similar like scale for map. So measures the ground distance covered by each pixel in an image. Lower GSD values mean higher detail. It means when you have a lower GSD values taken from the drone or satellite, obviously those images are useful for preparation of the large scale maps. And resolution encompasses spatial, spectral, temporal, and radiometric dimensions, indicating the overall detail and precision of the data. Okay, so resolution is also very important. So there is a direct link between scale, GSD, and resolution when it comes to preparation of maps for any application. And see, the map scale is photo distance by ground distance or image distance by ground distance. And we can represent scale in representative in the form of representative fraction or 1 by 25,000 or like that. And 1:10,000 typically expressed as a ratio or fraction, 1:10,000 or 1 by 10,000. Can also be expressed in words, 1 inch equals to 1 mile like that. And types large scale maps, medium scale maps, and small scale maps. Usually, when the number is less, it is a large scale map. 1 in 10,000, 1 in 1,000, these are all large scale maps. And 1 in 10,000, 1 in 50,000, like that, medium scale maps. And small scale maps, 1 in 50,000 to 1 in 250,000 are smaller. Okay, so the scale we can represent on a map with these different types of scales. One is large scale, medium scale, and small scale. And applications, large scale maps, we use urban planning applications, we use large scale maps. Cadastral maps, cadastral is nothing but your plot boundary or your property boundary. Cadastral represents your property boundary. So it requires very large scale maps. Basically, for accuracy, to achieve the accuracy, you need to use large scale maps. And most of the platforms in remote sensing, they usually flexible for preparation of either large scale maps or small scale maps. And especially when it comes to drones and aerial photos, drone images and aerial photos, obviously this large scale map is possible. And medium scale, regional planning, topographic maps, these are all medium scale maps. And small scale maps, national or world maps, including thematic maps of world, representing entire world, representing entire nation. That is what we call it as small scale maps. So the key point here is large scale maps show more details, while smaller scale maps cover larger areas with less details. And ground sampling distance, this is also the term that we already discussed. GSD is the distance between the centers of two adjacent pixels on the ground. It means it is nothing but straight away we can say that a spatial resolution of the image, spatial resolution of the sensor. And the spatial resolution, if the pixel is very small within a small area, and if the pixels are with small pixels occupied in a small area, and the same area, if you have larger pixels, then obviously the small pixels are nothing but low GSD values, and large pixels are nothing but high GSD values. Okay, so measured in units of distance. Usually this GSD measured in units of distance. And implications, when it comes to high GSD, each pixel covers a larger ground area, resulting in lower details. And low GSD, each pixel covers a smaller ground area, resulting in higher details. So this low GSD pixels or images are useful for preparation of large scale maps. And applications, similar like your small scale and large scale, high GSD, broad area monitoring, environmental assessments, lower detail requirements, whereas for low GSD images, detailed urban planning, infrastructure inspection, applications requiring high precision like that. Okay. So key point here is GSD is crucial for understanding the spatial resolution of imagery. Lower GSD values indicate finer spatial details. And there is a relation between GSD and the scale of the map, GSD and the scale of the map. And you can use this relation when it comes to the GSD can be calculated using the formula flying height with pixel size multiplied with pixel size divided by the focal length of the camera. So when you use any sensor, either in drone or aerial photo or aircraft, or the same sensor when you use in the satellite also. So you can calculate the GSD using this formula. Okay. So there is an example also. If altitude is 100 meters, pixel size is 5 micrometers, and focal length of the camera is 35 mm. In that case, GSD is 0.014 meters. It means 1.4 centimeter on the ground. Each pixel is representing 1.4 centimeter on the ground. And it means this is a low GSD value. We can generate large scale maps, very large scale maps from this image. Okay. If at all, if the image GSD is 1.4 centimeters on ground, representing 1.4 centimeters on ground. Okay. So this means each pixel in the image, let's say if an image representing 2 centimeter on ground, a pixel representing on an image 2 centimeter on ground, it is somewhat less scale compared to 1.4 centimeters on ground. Okay. So the image which has 2 centimeter GSD and the image which has 5 centimeter GSD. So with 2 centimeter GSD image, we can generate large scale maps compared to 5 centimeter GSD images. Okay. So this is how the equation works for generating maps using the GSD, referring the images. And image resolution, I told you already, it is a direct relation between, if the spatial resolution is high, it means we can generate large scale maps. If the spatial resolution is less, we can generate small scale maps. So spatial resolution and spectral capability of the sensor and the temporal capability of the sensor and radiometric resolution of the sensor. It all depends on, all these factors depends on your mapping accuracy. See, the spaceborne contains satellites, and you can see the satellite image captured from the satellite, and airborne is aerial photo captured by the aircraft, and drone photo, you can see more details are available in drone photo. It means very clear details are available in drone photo. Very small feature is also appearing on drone photo. It means the GSD is more in drone photo. The image GSD is more in drone photo. It means we can generate large scale maps using drone photographs and compare it to aerial photos and satellite images. And compared to satellite images, we can generate large scale maps using aerial photos. This is the equation that we need to know about how to process the large scale and small scale maps for various applications. And see, drones are still the best choice for areas where manned aircraft cannot fly safely. So restricted areas and not possible to go to the terrain and all. In those cases, such as very close to buildings, narrow streets or under bridges, while its line of sight, range and payload capacity are limiting factors, the technology is advancing quickly. So range is improving and sensors are getting smaller and more powerful. Previously, 5 years back, the sensors are not that much technology, that the powerful sensors are not available, but now the sensors are getting improved day by day, and cost of quality systems remains reasonably high. Technologies like drone in a box that allows drones to fly and charge themselves will expand their use capabilities. Regulations will need to evolve quickly to support these types of operations. Usually there are general guidelines given by the DGCA, Directorate General of Civil Aviation, and some restrictions are there. We need to follow those restrictions. And when it comes to drones, ideal for capturing small areas and to prepare large-scale maps. Resolution down to 2 centimeter or better. Drones currently require visual line of sight, VLOS. It means usually from the guidelines given by the DGCA, the drone must be visible to the pilot. the drone must be visible to the operator. So visual line of sight must be there when you want to fly the drone. And drones currently not authorized to operate over urban areas due to privacy concerns or in rural areas where fire may be a concern. And battery life is very important because nowadays the batteries are very important to fly the drone at least for 30 minutes or 40 minutes. Limitations on payloads reduces the size of sensors that drones can carry. This combined with altitude limits reduces the efficiency of capture. Okay, so this is the points that we need to note down while surveying the Earth using drones. And facts can fly below the clouds, so possible to capture in wider range of weather conditions and can be time specific. Well supported now by processing software automating much of the mapping work for the untrained operator. Cost of entry and operation is still significant for quality systems and limited geographically. Okay, so the drones only we can use for small areas, for detailed mapping, for large scale mapping. And aircrafts mostly similar like drones only. Only thing is the flying height and the pilot. It is drone is a pilotless instrument, but unmanned aerial vehicle. But aircraft is a manned vehicle. So that is the difference. And the flying height for aircraft is compared to drone, it is more like 3,000, 4,000 feet. But whereas drone, the restriction is 200 feet. The restriction is 200 feet. And satellites, when it comes to satellites, you can place satellites at 900 kilometer orbit or 30,000 kilometer orbit. So there is no restriction for satellites. So aircrafts, mostly the advantages of drone surveying is almost similar like aircraft surveying. Whereas when it comes to satellites, fast capture for very large areas. So mostly the satellite images covers large areas so that the mapping can be possible for large areas in a short period of time. Currently limited to 30 centimeter resolution. Usually this GSD is for satellite, the GSD, the product from the satellite is maximum 30 centimeter resolution. So far now it is available throughout the world when you consider. Whereas for drones, you can manage to produce 5 centimeter, 2 centimeter, even 1 centimeter resolution also. So that is the reason for small areas, we can prepare large scale maps compared to satellites and aircrafts using drone surveys. And types of drones, at least you should know types of drones that are presently available. And usually single rotor helicopters are one type of drone. Mostly the LiDAR sensors can be possible to operate from the single rotor helicopters for large lands, survey of large lands, like large extents. Okay, and also research kind of applications also we can use these single rotor helicopters. When it comes to multi-rotor drones are nothing but there are 4 propellers or 6 propellers or 8 propellers, 9 propellers. Okay, so depending upon the size of the drone and the number of propellers, we can say that that is a multi-rotor drone. Okay, so but usually some of the smallest and lightest drones, and they have limited distance, speed, and height compared to single rotor helicopters. Okay, so these drones can usually spend 20 to 30 minutes in the air carrying a lightweight payload. See, payload we will discuss in the subsequent slides, what exactly the payload and all. And fixed wing drones are like fixed wing drones look like normal airplanes where the wings provide the lift instead of rotors, making them very different, very efficient. These drones usually use fuel instead of electricity, allowing them to glide in the air for more than 16 hours. The advantage with fixed wing drones, previously for land surveying and all in AP and in other states, they used fixed wing drones to cover the large areas for preparation of cadastral or property maps. And payload is one of the important terms that you need to know. Usually the payload is nothing but the drone. Usually we send certain weight for from one location to other location. That what exactly, other than the drone weight, we are using the drone for sending or preparation of the surveys and all. Payload is the object or the entity which is being carried by an aircraft or launch vehicle. Okay, so the drone weight is not a payload. Actually, we are using a drone to transport certain weight from one location to other location. That weight is nothing but payload. It means if you are sending a medicine from one location to other location, and that medicine weight is nothing but payload. Or else, when we are sending a sensor for capturing the photographs for surveying, okay, that sensor weight is nothing but a payload for the drone. So there are different types of payloads, dispensable payloads, what we discussed about the medicine or food transporting from one location to other location. These are all dispensable payloads. Whereas non-dispensable payloads are nothing but the sensors that are already inbuilt sensors are available, and the sensor weight like LiDAR, like RGB sensor, multispectral sensors for mapping and other things. These are non-dispensable payloads. And active payloads and passive payloads are also a part of dispensable and non-dispensable payloads. Cameras, radars, and sensors, different kinds of payloads. When you talk about any camera, when you are using a camera in a drone, that is nothing but a payload. The camera weight is nothing but a payload. The radar sensors are also there. Those are nothing but the weight of the sensor is a payload. And sensors like drones use sensors to gather information about the world around them. Example, including sensors that track the weather, flight details, and perform other important duties. So the sensor weight itself is nothing but a payload for the drone. And what is a drone survey? Drones are powerful tools to help in the mapping and surveying industry. I told you already there is a comparison between traditional surveys and drone and aircraft surveys and satellite surveys. Ultimately, the surveying is nothing but capturing the features or observing the features, recording the features, and then processing the features for preparation of 2D and 3D maps. Okay. So similarly, with drones also, capture the images and process the images and prepare the 2D and 3D maps from the drone images. You have to use different softwares for processing the maps, processing the images, as well as processing the maps. Also, you need to use different softwares. So at every stage, the softwares are different. And obviously, you need a flight plan before doing a survey to prepare a map. Either it is a disaster map or a topographical map. To prepare a flight plan, you have a good understanding of the site. That is very important. Similarly, like a surveyor, he watched the area before doing a survey. No? Similarly, here also, at least you should know what kind of terrain that you are going for a survey and all. Okay. So when you plan to create a map, you will typically collect data using an automated grid flight pattern, using an automated flight path, will ensure that images are captured in a consistent manner and with proper overlap. Okay. So can create automated grid flights. And there are so many apps are available in the market. You can use the maps for controlling the drones and all. And this is actually the how you are going to collect the images for a particular area. So you have to start somewhere and take a U-turn, like it is nothing but your area of interest or project area shall be covered like this only. Some irregular shapes are there. Most of the project boundaries are irregular shapes, not regular. You need to plan accordingly to cover the entire area. And when you use a drone and all, these points are nothing but images. These points are nothing but these many number of images the drone is collecting for a small area. Let's say if your college campus is 26 acres or 30 acres and with a 50 feet high or 100 feet high with a 20 MP camera, 20 MP payload or camera, when you use, usually you will get more than 100 or 150 images covered for entire college campus. So similarly, you need to process for large scale areas also, large areas, geographical areas also. And the one of the important thing that we need to collect for creating a 2D map, you require very less overlap, but creating a 3D map, you require minimum 60 to 75% overlap between one image to other image. That is the photogrammetry technique. It means you need to triangulate each and every image with this overlap. Unless until you have an overlap of minimum 70% or 60% between the images, either it is side overlap or end overlap, you cannot create 3D images. You cannot create 3D maps. It is nothing but you cannot create 3D images, you cannot create 3D maps subsequently. So this overlap, maintaining this overlap is nothing but maintaining a common portion between the two images, adjacent images, or at least 70% of the common area must be available in every image, So that you need to take it into consideration. If the overlap is more and more, the accuracy of the map is also more. But remember, if you increase the overlap from 70% to 90%, the number of images will be more. It means the processing time also more using the softwares, and generating the maps time also, it takes a lot of time compared to 70% overlap images with 90% overlap images. And there are drones. When you say drones for various disasters, there are several drones are available in the market, mostly from even in India also, the drones are presently manufacturing by our local manufacturers. And also right now there are many drones are available throughout the world when you take. And these are all the drones specifically for different hazards, different disasters. For floods, you can use these two types of drones. And for earthquakes, you can use these models. And for wildfires, you can use these models. And because there is a difference between every disaster, when it comes to multi-purpose drones, you can use a single drone and keep different payloads or multiple payloads. You can use multiple cameras also. Similarly, what we are using in the satellite system, even in drone also, we can use multiple sensors to capture different images for different applications. So multi-purpose drones are also available, but it is costly when it comes to single-purpose drones. And floods, LiDAR cameras are very important. The payload is LiDAR when it comes to floods, helps in creating detailed topographic maps and identifying areas at risk of flooding. And multispectral cameras, also we can use it during the disasters, floods, useful for assessing water quality and detecting pollutants. And for earthquakes, high resolution cameras are very important, especially for detailed imagery, for preparation of large scale maps, where exactly the buildings are got affected and all. These can be known when it comes to high resolution cameras. And the payload for thermal cameras, usually the thermal camera payload is also available nowadays in the market. It means the sensors, thermal sensors are also available to detect heat signatures of survivors trapped under debris. Okay, so this is very important. Thermal cameras we need to use during earthquakes, after the earthquake or during the earthquakes for producing the maps. Thermal cameras are important. And at the same time, earthquakes, when it comes to wildfires, thermal cameras, similar like earthquakes, we also have to use thermal cameras as a payload for drone for preparing wildfires, managing wildfires. Okay, and landslides also. LiDAR and 3D mapping cameras are very important for landslides, because 3D is very important here, because we need to know the slope of the terrain. That is the reason LiDAR gives you very precise 3D measurements compared to any other multispectral cameras or any other cameras. So that is the reason the LiDAR is costly when it comes to any sensor that is available in the market. And hurricanes and storms, high resolution cameras are okay for hurricanes and storms, and multispectral sensor also okay. And tsunamis, high resolution cameras to capture detailed images of coastal areas. Thermal cameras are also important, useful for search and rescue operations to detect survivors. Thermal cameras usually can detect these species even in forest areas also. Okay, when a fire happens in the forest. And volcanic eruptions, thermal cameras are very important, because the temperatures are very important here when volcanic eruptions have happened anywhere. Okay, so essential for monitoring lava flow and temperature variations. To detect and measure, and gas sensor as a payload, we can use it for in a drone to detect and measure volcanic gases like sulfur dioxide and all. Okay, so these are the disasters, but for every disaster, the payloads are different. It means the sensors are different, and drones are also different models that we need to use. And key considerations when it comes to payload capacity, choose drones based on the weight and type of sensors required. Depending upon the weight of the sensor, we need to choose the drone also. Flight time and range. Obviously, some drones have larger flight times, but some drones are very small time flight. and weather resistant. Some drones are weather resistant, but most of the disasters, these weather resistant drones are very important. And data integration, utilize drones with capabilities to integrate data from various sensors for comprehensive analysis. So when it comes to the conclusion, by selecting the appropriate drones and sensors for each type of disaster, you can significantly enhance disaster response and management efforts. Okay, and once you collect the images using a drone, you can prepare 2D maps and 3D maps, ortho mosaic maps. Ortho is nothing but orthogonally rectified images. Once you collect the images from the drone or satellite or even from aircraft. Okay, and you can also prepare 3D models, digital elevation models, digital surface models. Digital elevation model represents only terrain, but digital surface model not only represents terrain elevations, it also represents each and every feature elevation also that is there on the earth. So the difference between digital elevation model and digital surface model. When you want to produce digital surface models, the cost of the project survey is more compared to when you want to produce digital elevation models. Usually the client, sometimes they may ask you to produce digital surface models, and some clients, they may ask you to produce digital elevation models, but the cost differs. Okay, so these are the products that we can generate from the drone surveys, from the drone imagery, raw images. Initially, raw images are there, and using the raw images, you can process the images in a software and then produce the maps like this. Ortho photos are nothing but two-dimensional ortho photos are there, three-dimensional ortho photos are there, 3D maps are there, digital elevation models are there. When you see a digital terrain model, digital surface model, and finally, you can prepare 2D and 3D maps also in the form of layers using a CAD or GIS software. Okay, so these are the outputs that we can process from the drone image processing. There are many outputs that we can generate from the drone images, and for scientific purpose as well as for engineering applications. And usually the accuracy of the drone survey is very important, and not only for managing the disasters, it is also important. The accuracy plays an important role even for engineering applications also. To prepare a DPR, you require a very large high precision data, and there are three factors that we need to know before flying a drone for processing the detailed accurate maps. So one is image overlap. I told you already, there must be minimum 70% overlap must be there between images to prepare 2D and 3D maps. And flight altitude level is also very important. Okay, when you use a sensor in a drone, with the same sensor, when you fly at 100 feet to capture the images, and the same drone with the same sensor, when you fly at 200 feet, obviously the GSD is, let's say, 2 centimeter when it comes to in the first case, and when it comes to second case, the GSD is 5 centimeter. So 2 centimeter GSD is more details are available in the images compared to 5 centimeter GSD. So the flight altitude is very important to prepare the large scale as well as small scale maps. And ground control points are very important. This is very important from surveyor's point of view. Usually, when it comes to traditional surveys, you require benchmarks and temporary benchmarks or permanent benchmarks in the form of XYZ coordinate system. Similarly, for drones also, you require ground control points to make the survey for a particular area. Okay, so these ground control points are very accurate points. You must have a very accurate ground control point. If your ground control point is not accurate, your data is also not accurate after surveys. Okay, so you need to take care of these ground control points. Usually we used to produce these ground control points using a DGPS instrument, using a DGPS or GNSS server. Okay, so factors affecting disaster mapping accuracy. Hardware considerations, you need to, drone platform is very important. Camera and sensors are also important for disaster mapping. And ground control points are very important here. And without the ground control points, we cannot achieve absolute accuracy. We can achieve relative accuracy, but we cannot achieve absolute accuracy if the ground control points are not accurate. And flight planning and navigation, and that is also important. Okay, so you need to plan effectively for surveying the area. Communication and data transmission is also very important, because these are the apps that we are using between one platform to other platform. Communication is very important. And processing hardware is also very important. Very high-end hardware is required. Very high-end servers are required to process the images as well as to process the maps, 3D maps or 2D maps. And weather resistance, choose a drone with weather resistance. That is very important for disaster management. And storage and data management is also very important. Every image, because there are hundreds of images you are capturing for a small area, it requires a data storage system also in your server. Okay, so every image usually occupies 1 GB space or 2 GB space. It means multiple images, thousands of images you are collecting, and the same thousands of images, if you download it in your software, obviously you require a high-end server. Okay, so regulatory compliance, upgradability, and maintenance, these are all very important for sustainable data processing. And I talked about relative and absolute accuracy. So this is very important when it comes to surveyor's point of view. Okay, so relative accuracy you can achieve without the ground control points, because the measurements will match with the ground. When it comes to a map that you produce from a survey, if the map is achieved relative accuracy, it means the measurements are matching with the ground features, but location accuracy is not matching when it comes to relative accuracy. But absolute accuracy, if a map is both achieved with relative accuracy as well as absolute accuracy, in that case, the map, each and every feature on map is matching with the ground. It means the location is matching as well as the measurements are also matching, either 2D or 3D measurements, whatever you call. Okay, so usually for engineering details and designs, absolute accuracy is very important when you want to do a survey. Okay, even using a drone survey or using traditional surveys, also your map should achieve absolute accuracy. Otherwise, you will be losing your application. Okay, so relative and absolute accuracy. And consequences of inaccurate disaster maps. Let's say when I prepare a map with a relative, the map is relative accuracy is achieved, but absolute accuracy is not achieved. In that case, what happens when it comes to disasters? So misallocation of resources. So resources such as emergency personnel, medical supplies, and rescue equipment might be sent to incorrect locations because absolute accuracy is not achieved in the map. Using that map, if you manage the disasters, you will be sending the resources to an incorrect location. In that case, leading to inefficiencies and delays in providing aid where it is most needed. And another one is delayed response times. Inaccurate maps can cause delays in response times as teams may struggle to find the exact location. That is very important. So the problem somewhere it is occurred, but on the map, the problem is in a different location because the map is not absolute accuracy. It is not achieved absolute accuracy. That is the reason leading to prolonged suffering and potentially higher mortality rates. Okay, in that case, when it comes to disasters. And increased risk to responders. Emergency responders might be directed to unsafe areas or roads, increasing their risk of injury or becoming victims of the disaster themselves. Okay, so this is also another point that we need to note while preparing the maps. Accurate maps are very important, even for engineering, even for disaster management also. In effective evacuation plans, evacuation routes and safe zones based on inaccurate maps can misguide the population, potentially leading to increased congestion, confusion, and higher casualties. This also may occur because of the inaccuracy of the map. And poor infrastructure assessment. Post-disaster recovery efforts can be hampered by inaccurate damage assessments, leading to improper allocation of reconstruction resources and longer recovery times. These are all the disadvantages that we have with the inaccurate maps when you produce using any traditional survey or drone surveys. So advantages that we can come to know with all the previous topics, we can straight away say that the advantages with drone surveying. Rapid data acquisition is possible and cost effective it is because we can survey the land within hours. And accessibility, sometimes if the area is not accessible, in that case, we can use drone surveys. Integration with GIS, easily we can integrate the data into any other platform, mapping platforms. And real-time monitoring enables real-time monitoring and assessment of ongoing disasters. Very important, no? So this is for disaster management. And historical comparisons, facilities comparison with pre-disaster data to assess changes and damage accurately. So that is important point that we need to note for drone surveys. And challenges and considerations, regulatory issues. Many countries have regulations. Even in India also, DGCA has given a lot of regulations, restrictions for using the drones for various applications. So height restrictions are there, and restricted areas, they mapped it in a map, and wherever you want to go, and it is not possible, you need to take permissions for certain drones and for certain applications, you need to take permission from DGCA and Ministry of Defense and even local police authority also. So data privacy and security. While drones provide significant data, there are concerns about privacy, especially in populated areas. The data collected must be managed securely to prevent misuse. Yes, so that is also we need to note. And battery life and payload limits are also important, because battery is one of the main thing to operate the drone. And weather limitations are also we need to check while flying the drone. And after all this, the applications of drones, already we discussed on many disasters and all, no? So agriculture operations, public safety and emergency response, and disaster preparedness. During disaster preparedness, risk mapping and hazard assessment can be done with different payloads or sensors, and infrastructure inspections are also possible with the drones. And training and simulation, drones are also useful in training emergency response teams. Very important, no? This is also for disaster risk force. And disaster response and damage assessment can be possible with the drone maps. Search and rescue operations are also possible with the drone maps. And delivery of aid is also important for transporting from one location to other location, like food, water, medical kits, etc. And real-time situational awareness. Okay, drones provide live videos, feeds, and real-time mapping of disaster sites, which can be crucial for decision-making and coordinating emergency responses. And assessing environmental hazards. Drones can fly into hazardous environments, such as toxic gas leaks. Very, very advantage that we have with drones, fires or nuclear accidents, to gather data on these kind of hazards. And disaster recovery. After disaster, during disaster, and then in recovery stage also, the drones are very much useful. Infrastructure inspection and restoration, reconstruction planning also possible with the drone images, and monitoring environmental restoration with the drone images. And post-disaster data collection is also huge advantage with the drone images. And post-disaster communication and coordination are also possible with the drone images. Okay. Disaster management in specific scenarios, flooding, wildfires, earthquakes, cyclones, and hurricanes. So the drones, where exactly we can use. Already we discussed about this, what kind of drones that we can use, and what are the payloads that we can use it for different hazards and disasters. And environmental monitoring and risk reduction is also possible. And there are some case studies, global status of drone usage in disaster management. So far in India, it is not up to the mark when compared to other countries, USA and Japan. So widespread use in disaster response by agencies like FEMA for tasks such as damage assessment in USA, search and rescue operations are going on in USA whenever the disaster happens in United States of America. Even in Germany and UK, those countries are also aggressively, they are using drones for disaster monitoring. And Japan also bit equal to USA and UK. But whereas in India, usually it is in starting stage only. Okay, so mostly private sector and startups are already available in the market because of the regulations released by the DGCA, because we should not import foreign drones and technology to the India to do some applications. That is the reason we are lagging behind the other countries. And you can see there are many case studies that are studied during the disasters in some of the countries. Hurricane Harvey in 2017, they used UAVs for rapid response and recovery during disasters like Hurricane Harvey's, highlighting the benefits of digital photogrammetry. Photogrammetry is nothing but image processing, 3D image processing. So Nepal earthquakes, post-earthquake damage mapping is also done by the satellite imagery. Not, see, when it comes to Nepal and India, we are using satellite imagery so far. We are using satellite imagery so far, not drone images. Okay, but now the drone images are also, we can use it, but the government has to has to be liberal for using the drones. And case studies, including California wildfires, are also with integrating UAV photogrammetry and GIS for damage assessment in post-wildfire management. They used this UAV technology in California wildfires in 2018. Similarly, Malin village landslide, application of UAV photogrammetry in landslide studies also it happened in India. Okay, this is one case study I have observed in the internet that has happened with UAV photogrammetry. It means drone photogrammetry techniques. And Japan tsunami also, they used LiDAR and earthquake, Japan earthquake and tsunami using airborne LiDAR. Airborne is nothing but they collected the pictures using aircraft and processed the images for monitoring the tsunami. So not drone images they have used in 2011, because that time drones are not famous. Thank you very much. Any questions are there? Please ask me.
Thank you, sir. Thank you very much. Sir, if you permit, I will welcome participants for question and answer session. Sir.
Yeah, please.
Yeah. Dear participants, I request you for a question and answer session. If you have any questions, you can raise your query, or you can text your question in the chat box. It seems no question from the audience, sir.
Yeah, a lot of things I discussed in the presentation. Probably for them it is not possible to follow all these topics technically.
No, sir. We are getting so many appreciations in the chat box, sir.
Yeah, thank you. Anybody? Any questions?
Shashidhar sir, are you there?
Yes, I'm there.
Yeah.
Sir, thank you very much, sir.
Yeah.
So, Raghu, if questions are not there,
Sure.
so we can close the section. Sir,
Yeah.
thank you very much once again.
Sir.
So thank you for sparing your time. Like because I am for the complete session, sir. Right from the 7:30 I was there, and I enjoyed it thoroughly because it's a new topic.
Yeah.
Like, and it's an advanced topic, and which is a very need of the day and the discussion of this technology. So
Yes,
thank you for enlightening all our participants, sir. Thank you very much, sir.
Thank you, sir. On behalf of organizing committee and the participants, I extend our heartfelt thanks for your invitation.
Yeah. You
On
can send the questions to my email also, so that I can give a reply to.
Sure, sir.
Somebody is asking how to ensure data privacy. We discussed about GSD, and we discussed about flying height, overlapping, and ground control points. All those are very important for achieving high accurate maps.
Sir, there is a question from Sharma.
Yeah.
Restrictions on drones for students flying for free in India?
No, it is not for students or researchers. Basically, when it comes to government organizations, they can take permissions easily for flying. But whereas for students and all, they can fly toy trains as well as micro trains under 25 kg weight drones. They can fly, but they need to follow the restrictions, height restrictions. Mostly 50 feet they can manage anywhere in India.
Okay. Sir, another question from Mahesh Kumar.
Yeah.
How to ensure data privacy from hackers?
Basically, that is an IT question. So ensure data privacy. usually you need to, your server needs to be perfect. Your server needs to be perfect because you are capturing the images through drones, and the images that you are directly collecting from the cloud, and then this is very important. The net and everything, your restrictions, passwords and everything must be perfect.
Yeah, sir, there is another question from Nagarajan.
Yeah.
What are the key factors to consider when training drone operators for disaster management, especially in high stress and time sensitive scenarios?
High stress and time sensitive scenarios. It's a good question. What are the key factors to consider when training drone operators for disaster management? Basically, when it comes to the guidelines from DGCA, a 10th class student can be a pilot to operate the drone. A 10th class student, minimum qualification is 10th class. Okay, so he can operate the drone, but only thing is he need to know, especially for surveying and preparation of maps and all. He must have a knowledge on engineering, surveying applications and all. And when it comes to drone operators, they can operate anywhere in India for disaster management. Only thing is they need a permission, especially in high stress and time sensitive scenarios.
Yeah, sir, there is another question from Nagarajan. What role drones play in reducing human risk during disaster response, particularly in hazardous zones?
So that is the reason DGCA has given a lot of restrictions, because you have green zones, yellow zones, and red zones are there. So for permitting to fly the drone, usually you need to, for some zones you require permissions usually. So and even for some applications, specialized applications like disasters and all, when it comes to government agencies like NDRF and other agencies, they can easily fly the drones without getting any permission from the DGCA. But as a local, as a public, you cannot manage without getting a permission from the DGCA.
Yeah, as I'm getting so many appreciation from the participants in the chat box, I request the participants, you can unmute yourself and you can communicate with Professor Ramesh Naidu.
How do drones assist in post-disaster image assessment? Because there is a slide especially for post-disaster damage assessment. So you can check the slide. You can check the slide. And how can this data can be used to accelerate recovery and resource allocation? Because especially for post-disasters, pre-disasters, there are specialized slides are available in my presentation. You can check and watch it.
Right, sir. Yeah. Thank you very much, sir. We are truly inspired by your contribution. I'm sure it played a significant role in success of our program. Thank you very much, sir. We hope to have the privilege of working with you again in future.
Thank you, Raghu. Thank you. Yeah.
Sir, with your permission, shall I close the session?
Yeah,
Please,
Raghu,
please.
I mean, announce tomorrow's program.
Yes, sir.
Actually, so many requests are coming to reschedule the FDP from 2 o'clock to 3 o'clock tomorrow. So let us discuss that, and morning we'll give you the clear program, please. All the participants. So tomorrow we'll have 3 sessions followed by examination. We'll post it by 10 o'clock. We'll post it tomorrow's program.
Okay, sir. Thank you very much, sir.
Thank you, sir. Thank you, Dr. Sashidhar, Professor Sashidhar. Thank you, sir. Thank you.
Sir, namaste, sir. Thank you so much, sir.
Thank you, sir. Right, sir.
Yeah.
Right.
Thank you, sir.
Shall I quit now? Yeah.
Yes, sir.
Yes, sir. Please, sir. With pleasure, sir.
Yeah, dear participants, as you are aware, tomorrow is the last day. Tomorrow we may have 3 sessions followed by online test and the valedictory. That schedule will be informed to you by tomorrow. Thank you very much.
Good evening, sir. But attendance is not updated, sir, till date on the ATAL portal.
Sir, we informed you several times. Attendance will be posted by tomorrow, sir. Why? Because actually we have running this program by with more than 150 student participants. ACTE has given a format, but that is not able to download it from ATAL portal, sir. Sure, we will uh, complete this task by tomorrow.
Okay, sir. Thank you very much.
Is there any question from the participants? Right. Thank you.
Hello. Sir, feedback session, sir.
వాటర్ ప్రూఫింగ్
కొత్త బిర్లా ఓపస్.
ఓహో తప్పు చేశారు. ఇంతకు ముందు వేసిందే వేయాల్సిందిగా.
కొత్త బిర్లా ఓపస్ వాటర్ ప్రూఫింగ్ యొక్క క్రాక్ ప్రూఫ్ టెక్నాలజీ తడి నుంచి కాపాడుతుంది.
అయితే ఏంటి? ఇంతకు ముందు వేసిందే వేయాల్సిందిగా.
బిర్లా ఓపస్ 10% పెయింట్ ఫ్రీగా ఇస్తుంది.
అయితే ఏంటి? ఇంతకు ముందు వేసిందే వేయాల్సిందిగా.
కానీ బిర్లా ఓపస్ 14 ఏళ్ల వరకు వాటర్ ప్రూఫింగ్ వారంటీ అందిస్తుంది. వీరిని కాలానికి వెనక నడవనివ్వండి. చూస్ కొత్త బిర్లా ఓపస్.